Hello everyone, welcome to our work, Conditional Text Image Generation with Diffusion Models. Let's have a quick preview. In this paper, we explore the problem of text image generation and propose a method called Conditional Text Image Generation with Diffusion Models. To conform to the characteristics of text images, we devised three conditions: image condition, text condition, and style condition, which can be used to control the attributes, contents, and styles of the samples in the image generation process. Specifically, four text image generation modes, namely, synthesis mode, augmentation mode, recovery mode, and imitation mode, can be derived by combining and configuring these three conditions. Extensive experiments on both handwritten and scene text demonstrate that the proposed TIG-DM is able to produce image samples that simulate real-world complexity and diversity, and thus can boost the performance of existing text recognizers. Next, let's expand on the details. Let's start with an interesting test. Please find real samples from the following handwritten text images and scene text images. I'll tell you specifically that 2 of each line are real in the handwritten text image, and a total of 7 are real in the scene text image. This may be difficult, so you can pause and take a look. Now we reveal the answer. On the left, the real images are the first and last of each row. On the right, the real images are even numbered. It can be seen that the quality of the images generated by TIG-DM is quite high, that one can hardly tell them from real images. If you can tell, you've got eagle eyes. Previously, a variety of data synthesis and augmentation methods have been proposed to enrich data for training stronger text recognition models. However, the augmentation methods fail to create OOV samples, and thus the diversity is limited by the training set. GAN-based methods are generally difficult to train and require careful design of hyperparameters, otherwise, it is easy to fall into mode collapse. Besides, most of the above data synthesis methods are only experimented on handwritten Latin text, without exploring generalization to other types of texts, such as scene text or handwritten Chinese text. Recently, a category of deep generative models, named diffusion models, has achieved impressive results in computer vision tasks. These works include DDPM, DIM, guided diffusion, glide, DALLE2, stable diffusion, etc. Unlike general image generation, text image generation requires more unique contexts and textural features at the character level. This inspires us to use a text recognizer to obtain conditions related to text images. This is the overall architecture of our approach. It consists of a conditional encoder and a conditional diffusion model. Specifically, the outputs of the conditional encoder consist of an image condition, a text condition, and a style condition. Specifically, image condition represents the unique visual characteristics of input images. We propose to use the encoder of a pre-trained text recognizer to obtain image condition that can better express general features rather than the noisy features. Text condition specifies the contents of the generated text images and represents the unique contexts among chars. Style condition describes the information about the writer styles and represents personal style rather than image style, which are only used in the handwritten text generation. Following DDPM architecture, the conditional diffusion model is trained with the proposed conditions. During the generation process, benefiting from the input of various conditions, we propose 4 image generation modes, namely, synthesis mode, augmentation mode, recovery mode, and imitation mode. The right table shows the details for each generation mode. In empirical experiments, the text condition determines the diversity and is helpful for OOV image generation, while the image condition and style condition influence the fidelity. On this page, we illustrate the image visualizations of different generation modes. Specifically, since the synthesis mode only depends on the text condition, we observe that its generated images have rich diversity. Handwritten text images exist in a variety of character slants, ink blots, cursive joins, stroke widths, and paper backgrounds, while scene text images are diverse in text rotations, backgrounds, blur noise, and fonts. Correspondingly, the image condition is more critical for the fidelity of the generated images. In augmentation mode, we find that the generated images are similar in overall appearance to the original images, but part details are lost in the specific characters. Images are more likely to generate wrong characters when the image condition is used solely. This is because only the image attributes are included in image condition, and the unique contexts among characters included in text condition are missing. After adding text condition, the generated images rarely have wrong characters and contain diversity at the same time. Finally, when style condition design for handwritten text is added, the fidelity of the generated images improves further, indicating that style condition plays an important role in image generation. For text recognition tasks, the ultimate purpose of generating images is to augment the training set and improve the performance of the recognizers. Therefore, we conduct experiments on multiple types of text recognition, including English handwritten text recognition, French handwritten text recognition, and scene text recognition. From the experiments on handwritten text, we can see that about 200K generated data can achieve comparable performance as the baseline. Besides, TIG-DM outperforms previous methods for data augmentation and data synthesis, and is complementary to previous works. From the experiments on scene text, it can be seen that TIG-DM is able to produce valid image samples that simulate the complexity and diversity of the real world, which can better improve the performance of existing mainstream text recognizers. In addition, we conduct several experiments on image generation quality, OOV image generation and domain adaptation. Benefiting from the proposed various condition and powerful generative ability of the diffusion models, our method outperforms the SOTA methods by a notable margin in all metrics on both datasets, which indicates the advancement of TIG-DM. Finally, we explore the applications of TIG-DM in other scenarios, e.g., the generation of OOV handwritten Chinese and ancient characters. On the left, similar to generating OOV words in English, we can construct radical sequences that are not in the training set to generate OOV Chinese characters, or create non-existing handwritten Chinese characters. On the right, one of the main difficulties of ancient text generation is the long-tailed distribution, i.e., it lacks training samples for rare characters. Our TIG-DM shows potential on it. Thanks for your listening.